Hi, my name is Shay, and I will be talking about Lab 2 for Dr. Schatz's class, which is about motion of a falling object. The topics of this lab include, basically we're going to be talking about a captured video showing a falling object, and we're going to be discussing the relationship with Newton's second law, including only the effect of gravity, and once again Newton's second law is Vf, final velocity equals initial velocity plus the net force divided by the mass of the object times the change in time. The first thing that was used was the tracker video, and I will show you my video. And this is what it looked like. As you can see, the ball is dropping from my hand. It's in slow motion. Next, we had a code. It was very similar to the first lab. I had to change the while loop, as you can see right here. I changed the time to 0.866 seconds because that was the final time from my tracker video. And then I had to add in weight, the ball, and I have the mass of the ball times g, which is our 9.8 meters per second squared, and then j hat, which is just letting you know that it's moving in the negative y direction. We also added a drag force later on, and I added that in my code. And also I have my F net right here, setting that equal to the weight force of the object. And then I added that into my Newton's second law equation right here where it says ball dot bell, and then also ball dot pause, showing the change in position of the ball. And in this case the ball is the paper, crumpled paper ball. Here's my graph from my code when I did not use the drag force and it was not included in, and as you can see there's a discrepancy in the graph from the code and from tracker. Tracker is the red dots up here, and the reason why that is probably because there was bad video quality and it was hard to tell where the center of the object was. Here's my graph with drag force, and it looks very similar. Once again, I did not have the best means for video quality. The first question was, what does it mean? If you look at the previous two graphs, you can see which one discusses the terminal velocity, and it's definitely the one with drag force because when the code was ran, you can see on this picture here that the drag force increased as the ball dropped, thus making the ball reach its terminal velocity. One of the other questions was, what if? What if the object was initially thrown downward rather than dropped from rest? The two objects, no matter what, should always land at the same time because of drag force. But when I ran the code, it showed that while they both obviously ended at the same time because I have it set to end at the same time, for my while loop, the second ball, or the time when I ran it, the ball traveled a further distance. So there was no setting of boundaries, so I would need to make a better code to see that. In conclusion, the main thing to get from this lab was Newton's second law, which is just again stating final velocity equals initial velocity plus F net over the mass, all multiplied by the change in time. Thank you for watching this video, and I hope you learned a lot.